everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve the given differential equation. So let's get going. Problem: solve d cube minus 2d square minus 5d plus 6 into y equals to 0 when x equals to 0, y equals to 1, when x equals to 0, y dash equals to minus 7, when x equals to 0, y dash equals to minus 1. So, solution. Given differential equation. D cube minus 2d square minus 5d plus 6 into y equals to 0, which is in operator form. F of d into y equals to 0. By comparing these two equations, we have f of d equals to d cube minus 2d square minus 5d plus 6. Now we are going to find the solution to the given equation using auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, replaces d by m to get f of m. Then you'll get m cube minus 2m square minus 5m plus 6. Now, our auxiliary equation will be m cube minus 2m square minus 5m plus 6 equals to 0. Right? Now, we are going to find the roots to the auxiliary equation. Okay. So, here we are going to use synthetic division method to find the roots of the auxiliary equation. So, we have auxiliary equation m cube minus 2m square minus 5m plus 6 equals to 0, right? Now, we'll choose for m minus 1, 1 minus 1, 2, minus 2. That is, we'll check which m satisfies the polynomial. Okay, firstly consider the polynomial. M cube minus 2m square minus 5m plus 6. Okay, now we'll see which m satisfies this polynomial. Firstly, let's see for m equals to 1. Simply substitute m equals to 1, then you'll get (1 minus 2 minus 5 plus 6) plus 1 plus 6 equals to 7. Minus 2 minus 5 is minus 7. 7 minus 7 is 0. So this polynomial m equals to 1 satisfies this polynomial, since this polynomial became 0 when m equals to 1. So we can say that m equals to 1 satisfies this polynomial, right? Now consider the synthetic division. (6 minus 5), simply write the quotient of m power 0, m square, m cube, minus 2, 1, right? So now for m equals to 1, 1 plus 0, 1, 1 ones are 1, minus 2 plus 1 is minus 1, 1 minus 1s are minus 1, minus 6 minus 1 is minus 6, 1 into minus 6 is minus 6, 6 plus 6 minus 6 is 0, right? Now, the next polynomial is m square minus m minus 6. Now we'll see which m, that is for m equals to 1, minus 2, 2, minus 2, for which m this polynomial gets satisfied. So let's try for 1. 1 square minus 1 minus 6 equals to 1 minus 1 minus 6 equals to minus 6, which is not equals to 0. So m equals to 1 does not satisfy this polynomial. Let's try for minus 1. Which is not equals to 0. This also does not satisfy. So you can try for 2. Okay. Or by looking at the polynomial, you can say that minus 2 satisfies this polynomial. Okay. Let's see for 2 firstly. Equals to 4 minus 2 minus 6 equals to 4 minus 8 equals to minus 4, which is not equals to 0. So 2 does not satisfy the polynomial. Now we'll try for minus 2. For m equals to minus 2. Okay. Minus 2 whole square is 4. Minus into minus plus 2 minus 6. 4 plus 2 is 6. Minus 6 equals to 0. So m equals to minus 2 satisfies the polynomial. So put minus 2 here. 1 plus 0, 1. Minus 2 into 1 is minus 2. Minus 2 minus 1 minus 2 is minus 3. Minus into minus plus 2 3s are 6. Minus 6 plus 6 is 0. Right? So here you are having m equals to 1. And here you are having m equals to minus 2. From this we'll get m minus 3. One factor. Okay. From the first one, m equals to 1, you'll get m minus 1 equals to 0. Here m minus 1 will be one factor to this polynomial. Okay, I'm not talking about the equation, I'm talking about the polynomial. Okay, you can split this polynomial to m minus 1 into, from this, here you're having in the second, you're having m equals to minus 2. From this we'll get m plus 2 equals to 0. From this we'll have one factor m plus 2 into, from the last one we'll have m minus 3 equals to 0. So you can split this polynomial as m minus 1 into m plus 2 into m minus 3. If you want, you can check it by multiplying. Okay, let's see what we'll get by multiplying these three factors. M minus 1 into m plus 2. Firstly, m into m square, m into 2 plus 2m, minus 1 into m, minus 1 into 2 is minus 2 into m minus 3 is equals to m square plus 2m minus m is plus m minus 2 into m minus 3, and this is equals to m square into m is m cube. M square into minus 3 is minus 3m square plus m into m is plus m square plus m into minus 3 is minus 3m. Minus 2 into m is minus 2m. Minus 2 into minus 3 is minus into minus plus 2 3s are 6 is equals to m cube minus 3m square plus m square is minus 2m square minus 3m minus 2m is minus 5m plus 6. So you got the same polynomial, right? Now, if we equate each factor to 0, you'll get roots. M equals to 1, m equals to minus 2, m equals to 3. So our roots are m equals to 1, minus 2, 3. Right? Or m equals to positive and then negative root. Okay, so here the roots are real and also distinct. We don't have any repeated root, right? And also these are real numbers. So we can say that the roots are real and distinct, right? So when we have three roots which are real and distinct, then our general solution will be y equals to c1 e power 1 root into x plus constant c2 into e power the another root into x plus c3 into third root into x. Okay, so our solution will be the general solution is y equals to c1. Consider 1 as m1, 3 as m2 and minus 2 as m3. Okay, e power m1 into x, that is 1 into x plus c2 into e power m2 for m2 equals to 3 into x plus c3 into e power minus 3 into x. From this you'll get y equals to c1 e power x plus c2 e power 3x plus c3 e power minus 3x, right? Therefore y equals to c1 e power x plus c2 e power 3x plus c3 e power minus 3x. Consider it as equation number A. Now we are having conditions, right? We are given conditions, so we'll find y dash and y double dash. Firstly, let's find y dash equals to c1 is constant, derivative of e power x with respect to x is e power x plus c2 into derivative of e power 3x is 3 into e power 3x plus derivative of constant, right? We'll get constant into derivative of e power minus 3x is minus 3 into e power minus 3x, right? So consider as equation B. Now find y double dash. Derivative of y dash is a y double dash. We'll get c1 into derivative of y dash. Derivative of e power x with respect to x is e power x plus 3 into derivative of e power 3x is 3 into e power 3x. Constant remains the same, minus 3 into derivative of e power minus 3x is minus 3 into e power minus 3x. From this you'll get y double dash equals to c1 e power x plus 3 3s are 9 c2 e power 3x minus into minus plus 3 3s are 9. One second. Here you have to get 2, right? Not 3. Minus 2. Okay. Sorry. This minus 2. So here you'll get minus 2, minus 2, minus 2. And here you'll get minus 2 into minus 2 into e power minus 2x. Fine. Minus to minus plus, 2 2s are 4. C3 e power minus 2x. Consider as equation C. By solving A, B, C equations, you will get C1, C2, C3 values. Okay, by using these conditions. So we'll see. We have equation A, equation B is y dash equals to c1 e power x plus 3c2 e power 3x minus 2c3 e power minus 2x and y double dash equals to c1 e power x plus 9c2 e power 3x plus 4c3 e power minus 2x. Now we'll apply the given conditions. When x equals to 0 and y equals to 1, consider A. Okay, A becomes, simply put, y equals to 1 and x equals to 1 in A. Then you'll get 1 equals to c1 e power 0 plus c2 e power 3 into 0 plus c3 e power minus 2 into 0. We'll get 1 equals to c1 e power 0 is 1 plus c2 e power 3 into 0 is 0. E power 3 into 0 is e power 0, which is equals to 1, right? Then you'll get c2 plus c3 into e power minus 2 into 0 is again e power 0, which is equals to 1. Then you'll get c3. Okay. So consider it as equation 1, right? When x equals to 0 and y equals to 1, we'll get 1 equals to c1 plus c2 plus c3. We'll consider it as equation 1. Now, when x equals to 0, y dash equals to minus 1. So, y dash, we need to consider equation B. Put y dash equals to minus 7 and x equals to 0 in equation B, then you'll get 7 equals to c1 e power 0 plus 3c2 e power 3 into 0 minus 2c3 into e power minus 2 into 0. From this we'll get 7 equals to c1 e power 0 plus 3c2 e power 3 into 0 is e power 0 minus 2c3 into e power 0. From this we'll get 7 equals to minus 7, okay? Not plus 7, we are given minus 7 here. Okay, equals to c1 plus 3c2 minus 2c3. So consider it as equation 2. So when x equals to 0 and y dash equals to minus 7, you'll get minus 7 equals to c1 plus 3c2 minus 2c3. Right? Now, when x equals to 0, this is our equation 2, right? When x equals to 0 and y double dash equals to minus 1. Consider equation C. Equation C becomes, put y double dash equals to minus 1 and x equals to 0, then you'll get minus 1 equals to c1 e power 0 plus 9c2 into e power 3 into 0 plus 4c3 into e power minus 2 into 0. From this you will get minus 1 equals to c1 e power 0 plus 9c2 e power 3 into 0 is 0 plus 4c3 e power minus 2 into 0 is 0. Since e power 0 equals to 1, then you will get minus 1 equals to c1 plus 9c2 plus 4c3. Consider as equation number 3. When x equals to 0 and y double dash equals to minus 1, you'll get minus 1 equals to c1 plus 9c2 plus 4c3. This is our equation number 3. Now we'll solve 1, 2, 3 equations to find c1, c2 and c3. Firstly, solving 1 and 2. We're having equation 1. 1 equals to c1 plus c2 plus c3, and equation 2 minus 7 equals to c1 plus 3c2 minus 2c3. Right? Now change the signs. Plus c1 minus 7 gets cancelled. You'll get 1 plus 7 is 8 equals to minus 3c2 plus c2 is minus 2c2 plus C3 plus 2C3 is plus 3C3. Consider as equation number 4. Okay. So our equation number 4 is 8 equals to minus 2C2 plus 3C3. Right. Now, solving 1 and 3. 1 equals to 1 C1. Okay, 1 equals to C1 plus C2 plus C3, and equation 3 is minus 1 equals to C1 plus 9C2 plus 4C3. Now change the signs. Plus C1 minus C1 gets cancelled. 1 plus 1 is 2 equals to minus 9C2 plus C2 is minus 8C2 minus 4C3 plus plus C3 is minus 3C3. So consider this equation as equation 5. Okay. We got equation 4 by solving 1 and 2, and we got equation 5 by solving 1 and 3. Now, we'll solve equation 4 and 5. Okay, so just compare these two. Here you're having 8 minus 8, and here you're having minus 2. So, we can multiply equation 4 by number 4. Then you'll get 4 into equation 4 gives 4 8s are 32 equals to minus 4 2s are 8C2 plus 3 4s are 12C3. Okay, now we can solve this and equation 5. Equation 5, 2 equals to minus 8C2 minus C3. 3C3, right? Now change the signs. Minus 8C2 plus 8C2 gets cancelled. 32 minus 2 is 30 equals to 12C3 plus 3C3 is 15C3. So from this you'll get C3 equals to 30 by 15, which is equals to 2, right? So therefore C3 equals to 2. Fine. Now substitute the value of C3 in either 4 or equation 5 to get C2 value. Okay, we got C3 equals to 2. Now we are going to substitute C3 in, let's substitute in equation 4. Then you'll get 8 equals to minus 2C2 plus 3 into 2. 8 equals to minus 2C2 plus 3 2s are 6. Now bring this 6 to LHS, will get 8 minus 6 equals to minus 2C2. From this we'll get 2 equals to minus 2C2. From this we'll get C2 equals to 2 by minus 2, which is equals to minus 1. So therefore C2 equals to minus 1. So we got C2 also. Now we need to find C1. So now consider equation 1. Here you can substitute C2 and C3 value to find C1. Okay, substitute C2 and C3 in equation 1. Then you'll get 1 equals to C1 plus C2, that is minus 1, plus C3, which is 12. You'll get 1 equals to C1 minus 1 plus 2. 1 equals to C1 minus 1 plus 2 is plus 1. Then C1 equals to 1 minus 1, which is equals to 0. Therefore, C1 equals to 0. We got all the three values, right? c1 equals to 0. Therefore, c1 equals to 0, c2 equals to minus 1 and c3 equals to 2. So our general solution will be, or the required solution is y equals to, substitute c1, c2, c3 values in equation A, that is actual solution, the solution obtained from this equation. We'll get y equals to 0 into e power x plus c1 minus 2 into e power 3x plus c2 2 into e power minus 2x. From this you'll get y equals to 0 into anything is 0, plus into minus minus e power 3x plus 2 e power minus 2x. From this you will get y equals to, first we'll write the term involving positive sign, 2 e power minus 2x, and then we'll write the term involving negative sign, minus e power 3x, which is the required solution. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.